Objects. Class collections.deque iterable max length returns a new deque object initialized left to right using append with data from iterable. If iterable is not specified, the new deque is empty. Deque are generalization of stacks and queues, and the name is pronounced DAC and is short for double-ended queue. This DQ support thread-safe, memory-efficient appends and pops from either side of the DQ with approximately the same O1 performance in either direction. Though list objects support similar operations, they are optimized for fast fixed length operations and incur ON memory movement cost for pop 0 and insert 0v operations, which change both the size and position of the underlying data representation. If max length is not specified or is none, DQ may grow to an arbitrary length. Otherwise, the DQ is bounded to the specified maximum length. Once a bounded length DQ is full, when new items are added, a corresponding number of items are discarded from the opposite end. Bounded lengths DQ provide functionality similar to the tail filter in Unix. They are also useful for tracking transactions and other pools of data where only the most recent activity is of interest. Deque objects support the following methods: append x, add x to the right side of the DQ; append left, add x to the left side of the DQ; clear, remove all elements from the DQ leaving it with 0; copy, creates a shallow copy of DQ; count the number of DQ elements equal to x; extend, iterable, extend the right side of the DQ by appending elements from the iterable left to right; extend left, extend the left side of the DQ by appending elements from iterable. Note, the series of left appends results in reversing the order of elements in the iterable. Index x, start, stop. Return the position of x in the DQ at or after start index start and before index stop. Returns the first match or raises value error if not found. Insert x into the DQ at position I. If the insertion would cause a bounded DQ to grow beyond max length, an index error is raised. Pop, remove and return an element from the right side of the DQ. If no elements are present, raises an index error. Pop left, remove and return an element from the left side of the DQ. If no elements are present, raises an index error. Remove the first occurrence of value. If not found, raises the value error. Reverse the elements of the DQ in place and then return none. Rotate n is equal to 1. Rotate the DQ n steps to the right. If n is negative, rotate to the left. When the DQ is not empty, rotating one step to the right is equivalent to d.append left d.pop, and rotating one step to the left is equivalent to d.append d.pop left. DQ objects also provide one read-only attribute: max length, maximum size of a DQ, or none is bounded. In addition to the above, DQ supports iteration pickling, length d, reversed d, copy.copy d, copy.deep copy d, membership testing with in operator, subscript references such as d0 to access the first element. Indexed access is O1 at both ends but slows to ON in the middle. For fast random access, use lists instead. Starting in version 3.5, DQ supports add multiplication and I multiplication methods. Example: from collections, import DQ. D is equal to DQGHI. From element in D, print element dot upper DQ. Close this one. Collections, then DQ. DQ example 1. From collections, import DQ GHI. Make a new DQ with 3 items. For element in D, element dot upper GHI. D dot append J. D dot append J. D dot append left. Print D. JHIF. D dot pop. Print D dot pop. F. J. Okay, append was J. D dot pop left. List D. List D. List version. D dot 0. In D dot 0. D dot D minus 1 I. List reversed D. IJH. H in D. Print H in D. True. D dot extend JKL. Extend JKL. Print D. GHI JKL. D dot rotate 1. Right rotation. Print D. D dot rotate minus 1. Left rotation. Print D. Again GHIJKL. DQ dot reversed D. Print DQ reversed D. Right. D dot clear. Empty the DQ. Empty DQ object. And D dot pop now is an exception because there is no element. Pop from an empty DQ. DQ recipes. This section shows various approaches to working with DQs. Both length DQs provide functionality similar to the tail filter in Unix. Diff tail file name n is equal to 10. Return the last n lines of a file with open file name as f. Return DQ fn. Another approach to using DQs is to maintain a sequence of recently added elements by appending to the right and popping to the left. Diff moving average iterable n is equal to 3. Moving average 40, 30, 50, 46, 39, 40, 40.0, 40.2. IT iterable D is equal to DQ iterator tools to slice it n minus 1. D dot append left 0. S is equal to 70 for element in D. In it, S plus is equal to element minus D dot pop left. D dot append element yield S by n. A round robin scheduler can be implemented with input iterators stored in a DQ. Values are yielded from an active iterator in position 0. If that iterator is exhausted, it can be removed with poplet, otherwise, it can be cycled back to the end with the rotate method. Round robin iterable, round robin ABC D E F, ABC D E F C. Iterables is equal to DQ map iterables while iterators try while true yield next iterators 0 iterator dot rotate minus 1. Accept stop iteration, remove an exhausted iterators dot pop left. The rotate method provides a way to implement TQ slicing and deletion. For example, a pure Python implementation of delete dn relies on the rotate method to position elements to be popped. Delete nth dn, d dot rotate minus n, d dot pop left, and d dot rotate n. To implement DQ slicing, use a similar approach applying rotate to bring a target element to the left side of the DQ. Remove all entries with pop left, add new entries with extend, and then reverse the rotation. With minor variations on that approach, it is easy to implement fourth style stack manipulators such as dupe, drop, swap, over, pick, rotate, roll. Thank you.